Hey everybody, Mr. Mias is here with you, and today on this video I'm going to talk about finding Z star for a confidence interval. So sometimes we're not given 95. In a previous video I did 90%, 95%, and a 99% confidence interval, and I told you how to find Z star in that, these are the most get normal model. These are the most common confidence levels that we use in AP statistics and regular and in a normal statistics course. We're going to see a 90%, a 95%, or a 99% confidence interval. Sometimes though we want to find something else like a 98% confidence interval. So if we're doing that and we don't have like a graphing calculator that'll just do it for us, we're going to need to determine what that Z star value is so we can find the confidence interval. So what I'd like to do on this video is just talk to you about finding Z star and maybe using a table to do that. Let's take a look. So we've got this normal model here, and our confidence interval for one proportion is p hat plus or minus Z star the square root of p hat q hat over n. This piece right here after the plus or minus, this is called our margin of error, right? So in our margin of error, here's what's happening. And this is a basic idea of Z star. This is not like, I'm not saying like this is the way it works. This is just like the kind of idea of what's going on, all right? If we're looking for a 95% confidence interval, we're looking to be 95% sure that the true proportion is somewhere in between, not in between this interval, in between our margin of error here. Right in the middle here is going to be our p hat. This is our point estimator, right? And our point estimate is going to be what we have to go out a certain margin of error. So this piece right here, this is our margin of error. So the question is, how far do we go out positively? How far do we go out negatively? That's what this plus or minus means here. How far out do I go to be 95% confident? Well, what tells me that 95% of the population is in between these two values? That is a Z score in the normal model. So the Z that corresponds to 95% confidence is what Z star represents. Z star basically is how much distance, how far away do I need to be to get 95%, or to be 99% confident, or to be 98% confident. How far away do I need to go? So that is kind of like our ruler, if you will, our ruler of how many standard deviations away from our point estimator are we going to make our margin of error. So the question is, how do we determine that? Well, it's really not that bad. Since we know that, what we're going to do is, let's say we want a 98% confidence. All right, we don't know the Z star for 98% confidence. So what I'm going to do is I am going to figure out what this Z that corresponds to the middle 98% is. There's a couple of ways you can do this. If you have a calculator, you can do this by doing inverse norm. Okay, so inverse normal will work. And the area for inverse normal for this problem will be 0.99. Now some of you are going, why is it 0.99? Why is that 0.9? So this is 2.33, it looks like. Why is the Z star for 98% 2.33 and I used 0.99 instead of 0.98? Well, the reason for that was because in my calculator, the calculator only does things all the way over. So it does this entire area. Well, if I do that entire area, if this is 98% in the middle, only 1% on this side and 1% on this side. So what is this whole thing? That's 99%. So that's what I have to use in my calculator. That's not saying 99% confidence. That's just what I have to put in the calculator in order to get that using inverse normal. All right? Same thing works with the Z table. So if I'm using the Z table, let's see if I can find my Z table here. Where is my Z table? There we go. So if I'm using my Z table, All right, I'm going to be looking for 0.99. Same thing I have to do because I'm looking all the way like that. All right, so let me look for 0.99. It's going to be on this one. Here's 0.9901. So that looks like it works out. That's close enough. We're going to get 2.33. So 2.33 is my Z star that corresponds to 98% confidence. All right. If I wanted 94% confident, well, let's do this problem here. All right. So suppose I take a randomly sampled group here. I'm just checking my time here because the bell's going to ring here soon. I don't want the bell to ring. All right. So you can read the problem on your own. Fast forward if you want. But who's that? Captain Marvel, of course. So I'm going to make a 92% confidence level. First question, what is the point estimate of the high school students who can identify this hero correctly? Well, my point estimate is 82 is p hat. P hat is 82 over 225. And 82 over 225, let's do that real quick in my calculator. 82 divided by 225 is 0.364. All right, so there's my point estimator. Okay, my point estimate. And so I'm on a confidence interval. So I'm going to go p hat plus or minus z star square root of p hat q hat over n. So p hat is going to be 0.364 plus or minus z star. I need a z star for 92% confidence. So thinking about this again here, we want 92% confidence. So 92%. All right. What's left over? 92 minus 100. So 100 minus 92 is 8. So that's 8 left over between two parts, which means there's 4 here and 4 here, right? 4 plus 92 is 100, which means all of this piece right here is 96. So I'm going to use inverse norm 96. Inverse norm 96. And I'm going to get 1.75. So 1.75 is my z star for that. 0.364 times 0.636, I believe, over 225. All right, let me make sure that's right. 0.364 minus 1.236. Boom. All right, so there you go, guys. This is how you find z-star, and it's you know, you just calculate that and interpret it like I did in the previous video. That's it. Finding z-star if you're given a different level of confidence. We'll talk to you soon. Bye. Well, I don't know if I'll talk to you, but you know, you'll see me. Bye.